Alright, we're going to talk about bypass capacitors here and a little bit about parts. We're going to continue a little bit more on libraries. I'm going to come over here to my components and file-based library preferences and tell it install, and you're going to find this file available on our web page. It won't be on the Canvas page. There should be a link on the Canvas page, and it'll go to the same place that you download Altium and you download all your libraries and stuff. You're going to find one that says ECE Library 21, and it's an integrated library. So I'm going to double click it to install it. There we go. I'm going to open up that library, ECE Library 21. I'm in the Components tab up here, and I want you to look at all these parts. We have a lot of parts in here. One thing we're going to look at is the potentiometers. Here's one that says offset. Here's one that says inline. I'm just going to double click this pot and stick it here. Right click to stop. I'm going to zoom in. Now if I look at this pot and I look at his properties, I can see the pins on here. Here they are. This is the way it's going to physically look on our PCB, pins 1, 2, and 3. But I have to worry a little bit about how are those pins laid out. What's actually going on with this guy? And almost every pot I've ever worked with in my entire career, we would have pin 1, pin 2 would be the wiper, and pin 3 would be the other pin. Now it could actually start off the other way. This could be pin 1 and this is pin 2 and this is pin 3, but pin 2 is always the wiper where you move the value up and down. That's the way this pot is wired in this library, and that works fine. If I go back to components over here and I go to the miscellaneous devices and I slide down and I find the pot, let's see, potentiometer, resistors, here we go. Here's a square trim pot. I haven't looked at that one, but there's potentiometers here, and this is a variable resistor, slightly different, but you'll find that the pins are going to be wrong. Let's look at this little one. I want to see how it works. This R pot, VR5, is the most common one that people will use. And I'm going to place it here, and you're going to see it looks similar. Looks almost the same. I'm going to look at the properties. I see the footprint slightly different footprint. But if I looked at the pins and the numbering on the pins, I'd find out that there's a problem. They have this as pin 1 or pin 3, the wiper. That's not going to work. When you put it in your board, you'd have to do this with the leads to make it work. Why they do that, I have no idea. I've never seen a pot like that in my entire career. I don't know why, but Altium does that. Don't get caught with that mistake. Don't use the pot that's in the miscellaneous devices. Use the pots that are in the ECE library. And when you look in that library, you'll see there'll be a lot of options. There's a lot of different pots in there. So you can pick which one do you want. There's all different pots. Let's get the right library here. So you see all these different potentiometers, and they have different part numbers and they have different footprints. If I place this guy, he's going to look the same on the schematic, but he's not going to have the same property. So look at this one. This pin in the middle is offset. When I look at this guy, those pins are in a row. So there's different options. Let's go back to our components. Alright, I don't know if I made a universal one. Let me stick that one on there. I don't want to spend too much time on this. Yeah, this one is in line and they're in the middle. So there's a lot of options here. Make sure you pick the proper footprint for your part, and you can just look at your potentiometer and see what does the footprint look like. I can always take any of these pots and point it to a different footprint. It's another option. So let's get rid of these. We don't need those. I'm going to go back to fit my objects, and we'll go back to capacitors. Now, when I have my project here, and I have my little op amp with my resistors and my input and output connectors and my power connector, but one thing I don't have control over on this project is where my power is coming from. So when I look at this connector up here, I don't know where the power is going to come from. It could come from a little power supply and it's 3 inches away. That may not be too bad as long as the connectors are good. But it may come from 30 feet away. Right? This might be some piece of equipment here that's going to go on a sensor on some project and it's remote and the power's coming 30 feet away. So 30 feet away means I'm going to have some resistance in my connectors, resistance in the wires. I'm going to have inductance in a long wire like that, so any kind of power requirements that this guy's using that switches fast, I may be switching something fast over here, well then the current's going to change fast, and now that fast current over that inductor is going to give me a voltage drop. I could be picking up noise on the power wires as they run across wherever they're going. Maybe this is on the outside of a Humvee with some kind of sensor and these wires are out there picking up electrical noise. So it's my job as the engineer to make sure I keep my power as clean as I can. So I'm going to put some filter caps up here. So let's come up here, back to our components again, and we're going to put some filter caps. Now, I don't want the ECE library for that. I'm going to take my miscellaneous devices, and here's a cap. It says capacitor. So I'll double click my capacitor. It's attached to my mouse, and you see it defaults. It says 100 picofarads. 100 picofarads is pretty small. I want something a little larger. Now, I could place that cap and then come over here and edit the value. There we go, make it 100 nanofarads. But I'd have to do that for every cap. That's going to take time. I don't want to do that. So I'm going to go back to place this cap, and I'm going to hit my tab key. Remember we did this with resistors. I hit the tab key and it pauses the placing and it brings up my properties. I'm going to come over here and edit this value and say I want 100 nanofarads. That's 0.1 microfarad. I'll unpause it. Now I can place my part. So I'll put one here and one here. So now when my power comes in, I'll hook grounds to those here in just a minute. I'll have a little filter cap. I think it would be smart if I also put one here and down here. So let's wire these up. I can make this come here, and I'll make that one come here. There we go. That one's wired in. I can put a ground here and a ground here, and I can wire that one in. Alright, so those are wired in now. I see my red squiggly line. Altium's warning me. What's it warning me about? My caps don't have designators. So I'll come up here and say Tools, Annotation, Annotate schematics quietly. I added those 4 caps. Yep, please update them. So now I have 100, 101, 102, 103. My caps are now annotated. Now I put a 0.1 microfarad on there because the 0.1 microfarad I'm going to use is a little ceramic capacitor. And when they say ceramic, that's exactly what they mean. It is ceramic. It's going to be a little piece, this is not ceramic, but it's going to be a little piece of ceramic, and they'll put a conductive plate on this side, and they'll plate a conductive plate on this side. So now you have two plates with a ceramic dielectric in the middle. When I put the leads on there, I have a capacitor. The advantage of the ceramic capacitors are they're fast. If I have a fast noise spike or a fast current pulse over here, these guys can react fast and they can help get rid of that noise. The downside is they're not very big. It's only 100 nanofarads. So if I have a very fast spike, my little ceramic cap works. If I have this low, long sag in the voltage, he's not going to help me much. So I need to add another cap. I need to have more protection. So let's go back. Here we go again. Components. And I'm going to put a polarized cap. Let me double click on that. And there he is. And he says 100 picofarads. No way. We know that won't work. I'm going to change that to 100 microfarads. Much larger cap. And you'll notice this guy has a plus symbol. He's polarized. He needs to hook up with the plus symbol being more positive than the other side, right, where the negative symbol would be. So I can place him here, but when I come over here, if I put it in this way, I'm going to have more positive on my negative lead. That's not going to work. Let's rotate him and put him like this. Now if I look at my cap, I'll wire him in while we're talking here, I can see that this capacitor is more positive up here than it is here. So this cap, the polarity is correct. When I look at this cap, I can see that this cap is more positive here than it is here. Let's zoom in. So I'm more positive here than here. So this cap is now correctly placed. If I put it in the other way, it would be reverse biased. These electrolytic caps, the types that we're going to use here, look like little cans, little round cans, kind of like my coffee cup with two leads coming out of the bottom. It's two long sheets of aluminum foil with a dielectric in the middle, and they roll that up and stick it inside that can, has some liquid in it, and that's the dielectric. The good part is it can be a large value and not that expensive. The bad part is it's not that fast. Because I have that long sheet of aluminum foil, two of them, I get inductance and I get some resistance, and then I'm rolling them together and there's some electrolytic in there, so all that slows it down. The advantage is it's very large. The disadvantage, it's slow. So when I put these two together, if you remember what happens when you put capacitors in parallel, they add. I go from 100 microfarads to 100.1. Doesn't seem like I'm gaining that much, but what I do gain is fast reaction time with this guy, large capacity with this guy. So I put them together, I gain. That's my big plus by doing this. Now these guys also not annotated. I'm going to go back to tools, annotate quietly. There's two. Thank you. Now I'm annotated. I'll do a save here. But I notice my part numbers are kind of out of order. There's 100, 101, 102, 104. If I want to be a little more organized, I can come back up here to tools and annotation and say reset the designators. Now they're all question marks again. And I can say tools, annotation, annotate quietly, proceed. There we go. Now I have a better order. 1, 2, 3, 4 are up here. Is that right? Yeah, 0, 1, 2, and 3, and then 4 and 5 down here. Yeah, things are a little more organized now. I'll do a save. So that's a little bit about caps and a little bit about why we choose the size of the caps we choose. And in case you wonder, why do I have a 0.1 here and a 0.1 here? That seems a little questionable, right? Why would I do that? Well, one of the reasons I do that, and here's a little circuit board you can see with some motors on it. I have my connection here, but then it routes this little thin trace all over the board to give me power. When I route it, maybe it's a long way for the power to get from here to here. And maybe this guy over here has fast switching speeds, so I get current pulses. And it'll start dropping voltage across that trace, very fast little current pulses across that trace because it has resistance and inductance. When I put this zero point 0.1 microfarad right next to this op amp, I'll get rid of that noise. I'll filter the power supply right by my op amp. So when you look at the schematic, you see these guys are right next to the power connector. I'm going to do that on my PCB too. I'm going to put those caps right next to the power connector. And then I have my op amp here with these caps right next to it on the schematic. I'm also going to put those capacitors. So my little op amp will be here. I'm going to put the cap right next to it so there's a very short connection to keep my power supply clean next to my op amp. You want to do this with every active IC on your PCB. And if your micro P has 2 power pins and 2 ground pins, you want to ground both ground pins. You want to put power on both VCC pins, your power pins, and if they're on opposite sides of the package, opposite sides of the microprocessor, put a 0.1 on this pin and a 0.1 on that pin, so you have caps on both sides. This will help keep your power supply clean and help your processor if you want to operate at higher speeds. It'll keep the power supply clean and help everything work. Alright, let me save there, fit my objects again, there we go. Alright, that's about all we have, finishing up with the bypass caps, and we did talk a little bit more about the libraries and the ECE library, the newest one, which is 21, and pay attention to your pot footprints. You don't want to use the one out of miscellaneous devices or you're going to be twisting pins or cutting traces. Alright, we'll start again with a new video.